Yeah. Yeah, we are live now. Please let me know whether I'm audible or not. Please let me know whether I'm audible or not. So accordingly, I'll proceed. Just any one of you message that whether I'm audible or not. Yes. Please let me know my audibility. Yeah. So today in this session, we are going to discuss mock HPCL paper, electrical. Okay. So we prepared the mock paper such a way that we prepared mock paper such a way that it almost replicates the actual examination in question level. We won't say that the same questions will come, but same level of questions will come. Okay. So yeah, I think I'm audible. I think I'm audible. So let's go ahead. Let's go ahead with the questions. Let's go ahead with the questions. Yeah, I'm taking the question series. I'm taking the question series HPCL Electrical. The very first question is from network analysis. Network analysis in HPCL, you all know that this time negative marking is also introduced. It's mandatory to read the question carefully. So in the last time there was no negative marking. Suppose if you don't know the answer, you tick something. Therefore, you get if you have luck or your prediction is correct, you'll get some mark. But there is no negative marking. But here negative marking is there. Luck is not going to favor you, right? So definitely we have to read each and every question. We have to read each and every question. Yes, carefully. If we know the answer in a clear way, then only we are going to answer. Otherwise, we are not going to answer it. Okay. Please make sure that. See, few tips I want to give. Some students ask me, sir, can you give any tips or tricks for this HPCL examination? Entire paper. See, first read the question. If you know the answer, tick it, then go to the next question. Like that, you do. Do not spend more time at a question where you are struggling for the answer. I mean to say, in the first step, solve all the questions or answer all the questions which you know in one go. Like you read the question, you are very confident about it, do it. Go to next question. Second question. If you feel second question is a little difficult or you need to do some analysis there, some more formulas you have to apply, or you are not that sure about the formula, leave it. Immediately leave it. Go to third question. Okay. Some people what they will do is they will spend in the second question by thinking that I know this concept. If I work on the question for more time, I will get. But your valuable time will be wasted because it's a competitive examination. Leave the second question, go to third. Answer third, fourth, fifth, sixth, seventh, ninth, tenth. Suppose if you feel 11th question is becoming difficult for you, leave it. Okay, just if you read it, if you feel that yeah, it is somewhat confusing for you, leave it. Go to the next question. Like that, in first go, complete all the questions, all easy questions you know. Second go, you start the moderate questions. Very difficult questions you leave for the last. In the last, if you have time, then you solve those questions. Otherwise, leave those very hard questions, right? Because some people they spend a lot of time at the hard question. They're going to waste the valuable time. In the last, they are unable to complete the known questions also because time is not there for them, right? Yeah. Read the first question. The first question is very simple. The power factor is defined as the power factor is defined as so power factor that is equal to cos phi is equal to P by S. It is a ratio of active power or real power to apparent power, right? Yeah. The options are the ratio between apparent power to reactive power, no. The ratio between true power to apparent power, yeah. This active power, this P is also called as active power. This is called as active power, or it is called as real power, yes, or it is called as true power. Okay, please do not get confused with the terminology. Some of you may not know that it is called as true power. Please know that it is also called as true power, right? So the option is the ratio between true power and apparent power. Question number one, option is B. Question number one, option is B. The second question is, read it. Point out wrong statement in the voltage technique of solving, node voltage technique, not just voltage technique, node voltage technique of solving networks. Choices of reference node does not. Means he's saying in nodal analysis, one node we are taking as reference. If you change the reference, If you change the reference, suppose, for example, see, understanding the question itself is an art. Okay, suppose there is a figure like this, there is a circuit like this. Okay, there is a circuit like this. I will take this one as a reference. Someone else will take this one as a reference. Someone else will take this one as a reference. Means three choices we have for reference. One, this is two, this is three. I'll solve this network by taking one as reference, someone with two, someone with three, someone with three. So does the choice of reference will affect? Yeah, option is what? Option is what? Change the voltage across any element. No, voltage across element is not going to change. So option A is wrong. Option B is affect the voltage of various nodes. Yes, node voltage may change. Suppose if I'm taking this one as a reference, suppose I'm standing here, this voltage is some value. Suppose if I'm taking this one as a reference, then this value is different because I have to travel this way, right? Option B, yes, it affects the voltage of various nodes. Next, affect the operation of the circuit. Nothing doing. Operation of the circuit is independent of what the hell technique you are using for solving that network. Next, affects the potential difference between any pair of nodes. No, that is also not going to get affected, right? The next question is third question. Third question. Read the third question carefully. The EMF induced in an n-term coil is given by minus n d phi by dt. We know this formula very well. The minus sign in this expression is due to Lenz's law. Yes, this is due to Lenz's law. Yes, the minus sign is due to Lenz's law. We all know that it is because of Lenz's law, minus sign, right? In transformer, yes, in transformer that minus indicates Lenz's law, right? Next question, question number 4. What is saying? The current changes from 4 to 6 amperes in 1 second induces 40 volts in a coil. The inductance is, yes, come here. I'm going to solve it. What he's saying is, he's having a coil. Yes, this is a coil. Simply inductor. Simply inductor is having a coil. What he's saying is, in this, current is changing 4 to 6. Means, what is induced in a formula? E is equal to di, in fact, not directly di, L di by dt. Yes, L di by dt. Induced EMF E. How much it is? Induced EMF E. How much he given? He given 40 volts. Induced EMF E is 40 volts. What is asking us to find? L, we don't know, into di. What is di? I2 minus I1. Change in current. He's saying that current is changing from 4 to 6. Then it's going to become 6 minus 4 by, in how much time? In 1 second. The dt is 1 second. Change of time is 1 second. Therefore, 40 is equal to 2 into L. That implies L is equal to 20 Henry. 20 Henry. Option is A. Option is A. You can expect at least one question in your HPCL examination from this inductance calculation, either self-inductance or mutual inductance, right? At least one question, I'm saying. Sometimes it may be possible to get more than one question, two questions also. But at least one question you'll find in entire HPCL paper of electrical from this self or mutual inductance calculation formulas, right? Next question is, what is the next question? A 200 volts 50 hertz inductive circuits take 20 amperes at a lagging power factor of 0.8. The inductive reactance of the circuit is. What is saying? He is saying that very simply. He is saying that 200 volts 50 hertz. How much is the current? See, fifth question solution. Current I is equal to V by Z. All are RMS values. 20 is equal to 200 divided by Z. I don't know what is Z. Z did not even. I have to calculate. So how much you are getting Z? Z is equal to 10 ohms. Keep it aside. Then what is cos phi? Even power factor. Even power factor. What is cos phi? Cos phi is equal to R. I don't know. By Z 10. Right? Yeah. Cos phi power factor is equal to R by Z also. Power factor is equal to, in fact, here itself I write that is equal to R by Z. Power factor, and it is not having any units. Power factor is not having any units. Right? Come here. Now, that is equal to how much power factor given? A given power factor value as how much? 0.8. The power factor is 0.8 given. Now from this one, how much is R? R is equal to 8 ohms. I have Z and I have R. Is it not possible for us to get the value of x? Easily we will get. What is z? Z is equal to r plus jx. If I want the magnitude, that is equal to root of r square plus x square. So z square is equal to simply r square plus x square. R square plus x square. Z is 10, therefore it is 100. R is 8, this is 64 plus yes, this is plus x square. So x square is equal to 36, x is equal to 6 ohms. The inductive reactance is simply 6 ohms. It is the inductive reactance is how much it is? 6 ohms. The option is A. Option is A. See, we have to make sure that we are reading the given data carefully. Okay, some people will feel like in this question data is insufficient. Data is very much sufficient, I will say. Right? And we have a solution also very simply here. Right? Now, read the question number 6. What question number 6 is saying? This fellow says that RMS value of current flowing through L1, L2, and C in the circuit below are 0.5 amperes, 0.3 amperes, 0.2 amperes respectively. The current drawn from the source is given a circuit. Yeah, I'm redrawing the circuit. Observe it. I'm redrawing it. He's saying that there is a capacitor, there is an inductor, there is another inductor. This is L1, this is L2, this is C. He's saying that this is carrying a current of 0.5 amperes, this is carrying a current of 0.3 amperes, and this is carrying a current of 0.2 amperes. Then how much is the current that is coming from this source? He wants this value of current I. So those are inductance and capacitance. Those are not direct, I can say, arithmetic summations. Those are vector or phasor summations, or vector summations, right? But though there are two inductors, these two are inductors. The current through inductors will remain in the same phase. So therefore, the current of inductors can be directly added. So how much is the total inductor current? IL is equal to 0.5 plus 0.3 is 0.8. IC is equal to 0.2. If you know the phasor diagram relationship, see the IL, suppose if I take some voltage, this is the voltage, okay, I'm taking ideal inductor. The current of ideal inductor lags the voltage by 90 degrees. This is IL. Let me give the statement again. The current through ideal inductor lags behind the voltage by 90 degrees. Same way, current through ideal capacitor leads the voltage by 90. So if you see, this IC and IL both are exactly in opposite. So this is how much I got? 8 amperes. Yeah, 0.5 plus 0.3. You can see here 0.5. Yeah, 0.8 it is, and it is 0.2. This is 0.2. If two currents are in opposite direction and the resultant current I source is equal to simply IL minus IC, because both are exactly opposite. If those are not exactly opposite, I have to take phasor summation by taking the angle also into consideration, right? This is 0.8 minus 0.2. This is simply 0.6 amperes. That's all. Answer is what? 0.6 amperes. So the option is B. Right? See, I expect you to solve some questions before I solve it. Yes, those who are listening to the class, yeah, please try to solve on your own. Okay, that fetches a lot in the actual examination, right? Yeah, sorry. Let's go to the next question. What is the next question? The resistance R of a conductor is given E, L, J, okay, I and all, okay. Where E is current electric field intensity, and J is current density. Okay, he mentioned very clearly, and we know the relationship also. Question number 7 solution I'm doing here. Current density J is equal to sigma into E. This is the formula. Please do remember it. Okay. Sigma is conductivity. E is electric field intensity. J is current density. Right. And sigma is conductivity, and rho is the resistivity. Rho and sigma both are reciprocals. Right. Rho and sigma both are reciprocals. Conductivity and resistivity both are reciprocals. Now tell me, J is equal to 1 E by What I do is J rho is equal to E. What I do is J into rho into L by A. Here also E into L by A I do. Right? Just on both sides I multiply with L by A. Just on both sides I multiply L by A. Then J into rho L by A is nothing but a resistance. This is E L by A. Therefore, resistance R is equal to E L by J into A. Either capital A or small a, it doesn't matter. Either capital A or small a, it doesn't matter. Right? So, which option is suitable? E L by J A. Option C is correct. Option C is correct. Yeah. Sir, sorry to interrupt you, but you should change the mic. It really doesn't sound well. Voice echoes a lot. Does it really? I don't think. See, let me check in my device, man. Let me check in my device. So let's go ahead. Let's go ahead with the questions. Let's go ahead. I think it's not. I think it's not giving any echo, man. Sorry, please change your. Sir, could you please zoom the screen? See, maximum zoom this much only. Maximum zoom I went for. That's why I'm reading each question. I'm reading each question carefully. Yeah, Anish, I'm reading each question. Please follow the question carefully when I'm reading itself. Okay, you can note down also. That much time I'll spare. Okay, no issues. Fine. I zoomed it, so that much only it is appearing. Right? Yeah. Let's go to the. I think my voice is okay. My voice is okay. Anish, my voice is okay, right? So somebody complained that it is giving echo. I don't think it is giving any echo. Right. Let's go to the next question. Question number 8. Question number 8. What is saying? Which of the following statements are correct for an ideal constant voltage current? Okay. Voltage. Uh, which of the following statements are correct for an ideal voltage source? Ideal voltage source. Yeah. Voltage source it is. Okay. Voltage source. He said which of the following is correct for an ideal voltage source? Option A. Its output voltage remains absolutely constant whatever the change in load current. Yes, that is ideal voltage source. Irrespective of the current, whatever the load is taking, the output voltage of ideal voltage source will remain same. Why? Because ideal voltage source internal impedance is 0. Statement 1 is perfectly correct. I am reading each statement, please. Okay. Second statement. It possesses zero internal resistance, so that internal voltage drop in the source is 0. Obviously, see, ideal voltage source internal resistance is 0. That's why the drop in the voltage source is 0. That's why, irrespective of load current, the output voltage remains same. Okay. Third statement. Output voltage provided by the source would remain constant irrespective of the amount of current drawn from it. Yes, third is also correct. In fact, the first statement and third statement both are same. Okay. Fourth one. Output voltage provided by the source varies with the amount of current drawn from it. No, this is wrong. So the option is D 1, 2, and 3. Option is D 1, 2, and 3. Here, in question number 9, that fellow given a circuit. I'll read out the circuit. Okay. Whenever there is circuit, I'll read out the circuit. Don't you worry. Okay. If it is not visible to you that clearly, don't you worry. I'm here. I do that. Okay. This is 6 amperes. This is 5 ohms. This is 2 ohms. This is 3 ohms. Yes, this is 3 volts. This is 3 volt. This is 1 ohm, in fact, that he given, and this even Vx. He's asking, yeah, he's asking, what is the value of Vx? Any one of you can solve? Yeah, please try to solve it. Try to solve it, please. Try to solve it. What is the value of Vx? He's asking. See, the voltage marked Vx is given by the marked voltage Vx is asking. You want this Vx. What is the method you are going to follow? See, you can do this one in any method. Okay, there is no. You can go with nodal analysis, or mesh analysis, or source transformation. This side I'll apply source transformation. Oh no, this side it is not possible. Not possible to apply source transformation. Okay, source transformation is not applicable. Okay. You can go with the KCL, KVL, Ohm's law, and all. We can do it. But what I do is very simply. What is the current in this one? current in this one is Vx by 1, right? Current is equal to voltage divided by resistance. Voltage is Vx by 1, Vx by 1. Now, as this is 3 volt, this is 3 ohm, the current in this one is 1 ampere. I want to write a KCL at this node. How much is the current that is coming to here? 6 amperes. Yes, 6 is coming. And in that Vx current is leaving. Then how much is this current? 6 minus Vx. Na? The current in this 2 ohms is 6 minus Vx. Right? Yes, I am taking a very good method. Okay, you people unnecessarily write a lot of equations, but I don't do that. Okay, I don't do that. Very simply, I do. Now, what I do is I write KVL for this part. If I write the KVL for this part, minus Vx, yeah, I'm starting here, minus Vx plus 2 into 6 minus Vx, 6 minus Vx plus what is the voltage here? 1 ampere is coming, or it is 3, this is also 3, this is 3 volt, 3 equal to 0. So minus Vx plus minus 2Vx plus 3 is equal to 0. So 3Vx is equal to 15. That implies Vx is equal to 5 volts. That's all. Vx is 5 volts. See the method what I taken. Always for any network analysis question, you see the current distribution. This method is called as current distribution method. I repeat, 6 amperes is coming from here. Okay, 6 amperes is coming from here. In this one, Vx is going. Vx is the voltage he given. Vx by 1 is the current in this. The remaining current 6 minus Vx will go here. According to KCL, 6 minus Vx will go there. So I know the current in this one. I know the current in this one. I know the current in this one. In terms of my unknown, I wrote the KVL. I got the Vx. Right. So this kind of solution is required. That will save you a lot of time in the examination. Right. Next question. Question number 10 is I read it loudly outside. Okay, you also please try to see it as the screen is not that much. Some people are saying that asking to zoom it, which is not possible here. Yeah, energy stored in a capacitor in terms of charge and voltage. He is asking energy stored in capacitor in terms of we know the formula half CV square, but he want in terms of Q and V, charge and voltage. Very simple. EC is equal to half into CV into V, where CV, Q is equal to C into V, right? So EC is equal to Q into V by 2, EC, or W is equal to Q into V by 2. Option B is, option A is W equal to 2Q. This is W equal to 2Q. No. Option B is W, energy, is equal to half into QV, half into Q into V. Option B is correct. This is half Q square, wrong. This is half Q square, which is also wrong. Option is B. Option is B, right? That much simple it is. Let's go to the next question. Let's go to the next question. Yeah. Observe it. That question is also very simple. He given a network. He given a network. Yes. The network, I'm redrawing it. Question number 11. I'm redrawing the circuit. He given 4 ohm. This is 6 ohm. This is 3 ohm. This is 4 ohm. This is 6 ohm. This is 3 ohm. Okay. And this is 12 volt. This is 12 volt. What he is asking? The power dissipation in 3 ohm resistance is, in this one, power dissipated in 3 ohm resistance is dash. Directly. There is no much logic or magic in this question. Directly you can solve. It's a direct question. First of all, 6 in parallel with 3, how much it is? 3 into 6 by 3 plus 6, 9. 3 3s and 3 2s. It is, this total is 2 ohms. 2 ohms plus 4 ohm. This is 6 ohm. 6 ohm by 12. 6 ohm by 12. This current is 2 amperes. This current is 2 amperes. Simply I can say. This current is 2 amperes. If this is 2 amperes, I want to know this current. Current through 3 ampere, 3 ohm is equal to 2 into, I am applying current division. Total current into opposite resistance by total resistance 9. So 3 2s, this is 3 3s. In fact, it is 4 by 3. So power in 3 ohms is equal to I square, 4 by 3 whole square into R. The resistance is 3 ohms. So 16 by 9 into 3. 3 3s it is gone. So 16 by 3 watts it is. 16 by 3, which is nothing but 5.33. 5.33. Right? The next one is a conceptual question, theory based question. The mass of an iron ion liberated at an electrode is directly proportional to the quantity of electricity. Okay, that is one of the law. Okay, is it Newton's law? No, it is not Newton's law. We know Newton's law very well, right? Is it a Faraday's law of electromagnetics? No, Faraday's laws of electromagnetic induction says that it gives the relationship between the flux and induced EMF and all, right? So Gauss law, that is also not correct. The Faraday's law of electrolysis is correct. Okay, this kind of no, Anish, it's not D. It is Faraday's law of electrolysis. So he is asking about the mass of an ion liberated at an electrode. Okay, is directly proportional to the quantity of electricity. It is not Gauss law. Gauss law talks about the flux, electric flux. Okay, it's not. It is not going to talk about. I can say a mass of an ion liberated at an electrode. Okay, please correct it, Anish. Okay, go to the next question. Go to the next question. What is the next question I'm reading here? A coil of 0.02 millihenry. Okay, just let me let me erase this solution part which is not required. I'm erasing it. Yeah. Which question we are solving? The question number 13 I'm solving, please. Question number 13. What is saying? He's saying that coil of 0.02 millihenry. So inductance value is 0.02 millihenry, right? Carrying a current of 1 ampere. It is carrying a current of 1 ampere. That is also fine. If the current is reversed means I1 is 1, I2 is minus 1. I2 is minus 1. So ion liberated does not mean for change cell. Okay. Anish, we will discuss it. You have my number now. Call me later. Okay. Let's complete this paper. Okay. See, Gauss law speaks about electric flux. Okay. It is not going to talk about the ions. Yeah. So he's saying that the current is a reverse from 1 to minus 1. It is changed. Fine. Within how much time? Within a time of how much it is? 0.02 seconds. Then what is asking? The induced EMF is previously given formula E is equal to L. L is 0.02 milli into di. Change in current is to I2 minus I1 by dt is 0.02. 0.02 is gone is equal to minus 2 millivolt is the answer. I think that is 0. Minus 0.0002 volt, but minus is not there in the options. He considered only magnitude. That's why option A is correct. That's why option A is correct, right? Actually, I2 minus I1. So di by dt, I2 minus I1 by T2 minus T1. I2 is reversal. See, 1 is the previous current. Now minus 1 is the new current. I2 minus of I1 it is, right? Yeah. Next question, please. Next question, please. The next question is question number 14. For a given voltage, 4 heating coils will produce maximum heat. He's saying that he's having 4 heating coils. This is one coil, this is another coil, this is another coil, this is another coil. This is 1, 2, 3, 4. These 4 coils together will produce maximum heating. Heating is maximum means energy is maximum. Energy is maximum means what is the energy formula? E is equal to I square RT. I square RT, right? Yes or not? What is I? What is I? I is V by R whole square into R into T. So energy produced is maximum. Energy produced is the inversely proportional to resistance. If less is the resistance, more is the energy, right? When you get a less resistance, if I connect all 4 coils in parallel, so answer is connected. All are connected in parallel. Answer is what? All are connected in parallel. Yeah. If you have 4 ohms, then you are going to get 1 ohm. You connect in any other way, you are going to get more than 1 ohm, right? Yeah. Next question. The time constant of an RC circuit is connected to a DC circuit is RC and the units are seconds. Whether it is series RC or parallel RC, the time constant is RC only, right? That is the direct question. Internal impedance of an ideal current source is ideal current source internal impedance is infinity. Okay, ideal current source, yes, ideal current source. This is with the open circuit in parallel to that. This internal impedance or internal resistance is infinity. This is the current source, right? Let's go to the next question, please. Let's go to the next question. Yeah. Next question is, let me read it loudly. The RMS value of the voltage is asking about the RMS value. Question number 17 I am solving. He given U of t. He is saying that U of t is the voltage. 2 plus 2 cos 2t. Its RMS value is RMS voltage is equal to under root of DC square plus this RMS value is what? 2 by root 2 whole square. This is the formula. See, DC square, yeah. Nickel Chube, answer is A. That's how, that is root 6 something. So RMS value is equal to root of 4 plus 4 by 2, that is equal to root of 6. The option is A. That's all. That's very simple. That is very simple, right? Let me erase this and let me go for the next question. Oh, fine. Yeah. Let me go for the next question. What is the next question? The frequency of signal is inversely proportional to which of the following? We all know that frequency is inversely proportional to the time period. If more is the time period, less is the frequency. That's all, right? So period. That is option is A. Okay. See why I taken this much simple question in HPCL actual examination. You got this kind of very simple questions also, just to replicate the previous papers and taken this kind of questions. And there are some good questions also. There are, see, 10% simple questions are there, right? Next question. The reactance of capacitors increased as, what is capacitor reactance formula? XC is equal to 1 by 2 pi FC. If you want this one to increase, then obviously we have to reduce the frequency. The reactance of capacitor increases as frequency if AC frequency decreases. If AC frequency decreases. Yeah, Anish, that's all correct. Next, which of the following statement holds for divergence? Okay. Question number 20, right? Let me read it clearly. Question number 20. Which of the following statement holds for the divergence of an electric and magnetic flux densities? Both are zeros. No. These are zeros for static densities but non-zero for time-varying densities. No. It is 0 for the electric flux density. No. It is 0 for the magnetic flux density. Divergence. Okay. Please go through the EMFT formulas, especially divergence, curl, and Maxwell equations. There are 4 Maxwell equations. Divergence, curl of those divergence and curl operations of those equations. Please go through it. Okay. So these are, see, direct formula questions from EMFT. Okay, nothing calculations. You can check previous papers. That's why I taken direct formulas. Question number 21. What is question number 21? The Maxwell equation for time varying field is, this is directly option A. The Maxwell equation for time varying field is option A. The force experienced by a conductor lying in a magnetic field is, you know, this question is from intermediate. Okay, this question is from intermediate, not from I can say BTech. That is force developed in a magnetic field which is carrying current is B into I into L into sin theta. Generally, at my childhood, I studied as Bill sin theta. Okay, as Bill is the term which we most of the times uses, but it is BIL sin theta, where B is the magnetic flux density, I is the current carrying, and length is L is the active length of the conductor. What does it mean by active length of the conductor? Suppose this is the magnetic field. This is the magnetic field. Okay, this is north pole. This is south pole. I am taking this much length the conductor. But active length means only this length only, from here to here only we have to consider, because that is only the conductor which is actively in the magnetic field. That is only the conductor which is there actively in the magnetic field, right? Next, Maxwell equations of free space can be given as, yeah. So these are not deltas. These are not triangles. These are these symbols. Okay. Yes, and this option is C. That is direct formula. That is also direct formula. Sir, could you please recall when we use BAL sin theta? Yeah, I'll recall it. Yeah, Anish. When we use BAL sin theta, see, you know, torque equation what we develop in DC machine is torque equation which we got in DC machine by from BAL sin theta only. Okay, see, suppose I'll say this is north, this is south, and this is the magnetic field. Here keeping one conductor like this. Here keeping one conductor which is carrying a current of I. Then definitely this conductor is going to experience some force. The direction of force is given by Fleming's left-hand rule. Yes, I taught in classes. The direction of force is given by Fleming's left-hand rule. Means put the north to south. Okay. Then current the direction is given by this middle finger. Then this thumb indicates the direction of rotation. Okay. Suppose if he gives some figure, he may ask you to find the direction of rotation, or he gives magnetic flux density, length, and current. Theta. What is theta? This is the angle theta. This is the angle theta. Okay, the angle made by the conductor with the magnetic field. Suppose if it is straight, it is 90. It is 90. Suppose if it is exactly horizontal like this, angle is 0. Okay, angle is 0. So BLV sine, yeah, no, BIL sine theta is force. BLV is for induced EMF. Induced EMF. Okay, Anish, please go through it. Okay, not BLV. Okay, E is equal to BLV sin theta. E, induced EMF, is equal to BLV sin theta. This is force is BIL sin theta. BIL sin theta. Right? Yeah. Fine. Let's go ahead. Okay. I think previously we had left with some questions. Do we? No. Up to 23 we are done with. Okay, fine. Come here. Next question is the electric field intensity. Question number is how much more? Yeah, 24. The electric field intensity and E and electric flux, these are directly related. Okay. Yeah, that is question number 24. No much explanation required from that because those are very EMF basics. 25. Which of the following statements is true? Electric charge can produce electric field and a magnetic field when stationary. Now, let me give one statement directly. That is also a direct statement. That is, when electric charge is stationary, it will produce only electric flux. When it is moving, it is able to produce magnetic flux. Right? Electric charge can produce electric field when stationary, but both electric and magnetic field when it is moving. Option is B. A moving charge will produce both electric field as well as magnetic field. But a stationary charge will produce only electric field but no magnetic field. Right? An electric dipole consists of, what is a dipole? See, some questions in your HPCL paper they given from intermediate syllabus +1, +2 syllabus physics, not +1 exactly, +2. Okay, for mechanical they may be giving +1 physics, but +2 physics is completely related to electrical and electronics. Okay, that's why I picked some questions from there, right? So two equal and opposite charges separated by some distance, and then that forms a dipole. See, two equal and opposite charges, sorry, minus q, plus q and minus q, separated by a distance of very small. This L is in nanometers or micrometers or less than that. Okay, then this forms a one dipole. This is a dipole, right? The option is D. The option is D. Okay, fast it. I'll fast it up, ma. Okay, because we have to solve all 85 questions in a single go. Which of the following statement is true for divergence of electric and magnetic flux densities? It is 0 for magnetic flux density. Yes, it is 0 for magnetic flux density. This is also that statement. Next, according to Gauss law, the surface integral of the normal component of electric flux density D over a closed surface containing charges equal to C. That is Q. Okay, that is going to give the total charge that is enclosed in that body. Okay, let's go to the next questions part. Next questions part. That is question number 29. Yeah, question number 29. Read question number 29. What is saying? If both the junctions of BJT are forward, then BJT is in dash region, saturation region. That is very simple thing we all know. Okay, that is in saturation region, right? A sinusoidal AC voltage source feeds a pure inductor through a diode as shown in figure. The duration of the conduction of the diode in one input power cycle is 360 degrees. Here, there is a long derivation which is not required here. There is a long derivation which is not required for you. Whenever there is an ideal inductor and diode, the diode conducts for all 360 degrees because inductor does not allow sudden change of current in it. Therefore, it continues to conduct. See, in power electronics, you might learn with the pure L load, pure R load, RL load at all. If it is pure inductor, it is 360 degrees. You can remember also. Yes, we can derive. We can derive. You can write the equations or you can draw the waveforms. You can get the same. But in examination, all that is not required. Just you remember, if there is a pure inductor, pure ideal inductor, it is going to conduct for all 360 degrees. 31. In a clipper circuit, DC source is set to 0 voltage. Then the circuit is like, yeah, in a clipper circuit, the DC source is set to 0 voltage. It is acting like a rectifier. Obviously, it is acting like a rectifier. Next question. The diode under forward bias condition blocks current, no. Drops a large voltage, no. Has a high resistance, no. It conducts current, that's all. See, in forward bias condition, it is going to offer conduction. In reverse bias, it is going to block the current. Next question. Question number 33. What is saying? An 8 pole. Question number 33. That is, number of poles is equal to 8. And he is saying that simplex wave winding. See, it is lap winding, number of parallel paths is equal to number of poles. It is wave winding, number of parallel paths is equal to 2 always. A is equal to 2. Yeah, wave winding means A equal to 2. A is number of parallel paths. Contains 32 coils. 32 coils of 6 turns each. One coil means the total number of conductors is equal to 32 into 6 turns into each turn is going to have 2 conductors. Therefore, total number of conductors is Z is equal to 32 into 6 into 2. And it is high flux per pole is of 0.06 Webers. The machine is running at 250 RPM. Then the armature voltage is EG, generated EMF is equal to 5ZNP by 60A. You substitute it, you must get the value of 384. Good. Anish, 33 is C. 33 is C. Okay, you solve it, you must get that substitute all those values you substitute one, you're going to get 384 as the answer. Okay. Yeah. Next question. What is saying? For question number 34, no pen paper required, directly will answer. Question number 34, anyone with the answer? Question number 34. No pen paper required for question number 34. If you read the question carefully, you get it. If you read the question carefully, you get question number 34 easily. Right. So what is question number 34? The DC generator runs at a speed of 1000 RPM and flux per pole is 0.2 Webers. Number of poles are 2. The winding is wave wound and having 480 conductors. Okay. The critical speed is 1200 RPM. Then the generated EMF is 0. Why? Why? The running speed is less than the critical speed. Yes. Critical speed itself. What is critical speed? It is the speed at least above which the generator will have to rotate such that EMF will be induced. Otherwise, EMF will not be induced. That is the critical speed. The speed of the generator is less than critical speed. It is running at 1000 RPM, which is less than 1200. Therefore, 0 induced EMF. Next, shunt generators are most suited for stable parallel operation for their voltage characteristics are drooping characteristics. Yes, sir. The shunt generator characteristics are called as drooping characteristics. This way, those characteristics are drooping characteristics. Right? Next question, please. Yeah, read the next question. Okay, just let me adjust this page. The residual magnetism of a self-excited generator is lost. To build up its EMF again, yeah, the field winding must be excited with low voltage DC supply. Yes, this is that theory question. This is a direct theory question. Okay, so we have to excite the field winding again. Field winding must be excited with high low voltage DC supply. Question number 37. Why is the armature core of a DC machine is laminated? See, lamination either in DC machine or in transformer used for reducing eddy current losses. People may say, sir, in DC machine the voltage is DC, current is DC, frequency is 0. Then what about eddy current losses? Eddy current losses are going to depend on frequency. As frequency is 0, eddy current losses are 0. No. DC outside what we are getting is a DC. But inside of the machine, in the armature core, the generated EMF is AC only. It's not DC, right? Next, which of the following does not have a commutator? Dynamo, it requires a commutator. Universal motor, yeah, DC series motor, yeah. All DC machines are having, I can say, this commutator. One that does not require dynamo, that commutator is induction motor. Induction motor does not require any commutator. Okay, what is the purpose of commutator in DC machine? You know it very well. In DC motor, it is different. DC generator is different, right? In DC generator, it is converting from inside generated AC to DC outside DC. In motor, we are giving DC. That DC is converted to AC inside for DC motor, right? Next, 39. An 8-pole lap-wound DC shunt generator is supplying 295 amperes to the load. The field current is 5 ampere. The current per parallel path is, what is the total current armature current IA? That is equal to IL plus ISH, as it is which motor? It is a shunt motor. DC shunt generator. It is. So 295 plus 5 will be 300 amperes. Fine. Yeah. It is said that lap wound. It is lap wound. So number of parallel paths A is equal to number of poles. Number of poles are 8. Number of poles are 8. Now current per parallel path I per A is equal to IA by A. How much it is? 300 divided by 8. How much you get 300 divided by 8? It is simply 37.5 amperes. Yeah, option is D. 300 divided by 8. Never it is A, B, C. It is D only, right? The calculation I'm talking about, right? In transformer, zero voltage regulation at full load is E on zero voltage regulation. See, zero voltage regulation is possible. First of all, what is voltage regulation formula in transformer or in transmission line? See, voltage regulation. Let me write here. Voltage regulation is equal to percentage R, percentage voltage regulation, percentage R into cos phi R plus or minus percentage X into sin phi R. This is of line. This is also of line or machine. In transmission line, we take it as line. In transformer, we take it as a machine only R. Now, this is equal to 0 if and only if this is minus none. So, in that formula, plus for lag loads, and we know that minus for lead loads, right? So, this is minus for what loads? Possible only for at leading power factor loads. 40 is option C. Right? Next one. Yeah. Let's go to the next question. The magnetic inrush currents in an unloaded transformer is maximum when the switch is closed and the voltage is passing through 0. Yes. Why? Because and when magnetic inrush currents are flowing, we have to consider the relationship of inductor. The inductor, if voltage is 0, then current is maximum. Right? If you draw the characteristics of inductor, ideal inductor voltage current characteristics, if this is the voltage you take, current lags behind it by 90 degrees. Therefore, current it starts here. You see, when the voltage is 0, then current is max. When voltage is 0, current is max. Right? When voltage is 0, current is max. You see, when voltage is 0, current is max. Option is A. Next, 42. A 2 kVA transformer has iron loss of 150 watts and full load copper loss of 250 watts. Okay. The maximum efficiency of the transformer would occur when the total loss is at a maximum efficiency. You know, iron loss must be equal to copper loss. Oh no, that's wrong. Copper loss is equal to iron loss. See why? Because iron loss is fixed. Copper loss is going to depend on the load, but iron loss is going to depend on the voltage and frequency. Once voltage and frequency is fixed, irrespective of load, iron loss is fixed. At a maximum efficiency, copper loss is equal to iron loss. Therefore, both the losses are equal. What is the iron loss? 150. So total loss is equal to 150 plus 150, 300 watts. Many people will think for 500. It's not 500. Okay. Yes. No, Anish. If induction current is, he is asking about maximum. Yeah. See, you are right. He is asking a maximum current. He is asking about. Then definitely voltage is minimum. Na? Your statement is exactly converse to it. When current is minimum, voltage is maximum. That is the relationship between the inductor voltage and current, right? Yes or not? Just look at it. Question number 42. Yes, it is. We have to take iron loss. Copper loss is equal to iron loss, not iron loss is equal to copper loss. Okay. Otherwise, if you take iron loss is equal to copper loss, copper loss is 250. Then total loss is 250 plus 250, 500 will be, right? It is not correct. Yeah. Let's go to the next question mark. Yeah. Now, what is the purpose of instrument transformers is the next question. See, instrument transformers are used to extend the ranges of ammeters, voltmeters, and wattmeters. All methods can be extended with help of instrument transformers, right? Next, an auto transformer having a transformation ratio of, so he's saying that K equal to 0.8 and a load of P is equal to 10 kilowatt. The power transferred inductively from primary to secondary. So inductive power transfer is equal to total P into 1 minus K. The conductive power transfer is equal to P. If I add these two, P into K, sorry, if I add these two, then I must get it as total P. So he's asking about this one, that is a power transfer inductively is equal to 10 into 1 minus K is 0.8. That is equal to 0.2 into 2 is 10 is it is 2 kilowatt. The option is A. 44, the option is A. 44, the option is A. The function of oil in a transformer is provided insulation and cooling. Option is A. Protection against lighting, nothing to do with the lighting. Protection against short circuit, nothing. Lubrication, nothing. If there is any moving part in the transformer, then we can think about the lubrication and all. There is no moving part in the transformer. Therefore, just it is to produce cooling and insulation. That's all. Yeah. This is a good question. 46. EMF per turn. What is that? Let me write something over here. What is the EMF? E1 formula. E1 is equal to 4.445 F into number of turns on the primary side. Right? EMF on the secondary side is equal to again 4.445 F and N2. Now EMF per turn, what is that? E1 by N1 is equal to 4.445 and F. That is equal to E2 by N2. Yeah, you take this N2 to this side, you are going to get 4.445 F. Means EMF induced on both sides, LV and HV per turn is equal. I am not saying the total EMF. EMF induced per turn on primary and secondary both are equal. Therefore, which option is perfectly suitable for the given question? Both winding have equal EMF per turn. Option is B. Some people out of hurry, they think that on HV side more EMF. Yeah, HV side total EMF is high, more, not EMF per turn, right? Yeah. Induction generator delivers power at leading power factor. Induction generator delivers power at a leading power factor. Yeah. Option is D. That is a direct question. Yeah. The next question, read the question number 48. What is saying? The question number 48 is what is the operating slip of 400 volts, 50 hertz, 6 pole, 3-phase induction motor while speed is 936 rpm with a speed with the 400 volts of 48 hertz 3-phase supply. He's asking about slip. Okay. What is slip formula? S is equal to Ns minus Nr by Ns, but Ns is changing, but because here the frequency is different, here the frequency is different. What is Ns formula? Let me do it. Let me do somewhere over here. Yeah. Ns is equal to Ns1 120 F. F is 50 by P. How many poles it is? 6 poles. What is Ns2? Ns2 is equal to 120 F 48 by P. And how much at what speed it is running? Nr 936. So in these two, which Ns I have to consider? This one only. This is not required to consider because our frequency itself is 48. Therefore, definitely synchronous speed will change. Now you are going to get some value. Then slip S is equal to Ns 120 into 8 by number of poles are 6 minus 936. Ns minus Nr by Ns 120 into 8 by 6. Solve this, you'll get the answer. Solve this, you're going to get the answer. Yes. Please, anyone can give me this value? Yes. Otherwise, you can do it the calculation on your own when you feel time. When you feel the time. 48 is also done. So the 3-phase induction motor, the maximum torque is, what is the torque formula, maximum torque formula of 3-phase induction motor? Maximum torque is equal to sum K into E2 square by X2. Are directly proportional. Instead of writing this one as this way, right? E2 square. E2 means induced EMF in the secondary, or this can be written as V2 square by X2. Is it having anywhere resistance in its? I can say formula. No. So it is independent of resistance. Right? Next question. Which of the following is false in an induction motor? The value of maximum torque is dependent on. It is going to dependent on which of the following is false. It is depending on rotor voltage. Yes, it is depending on rotor voltage. Frequency of AC supply. Yes, X is going to depend on frequency. X is equal to omega 2 pi FL. Right, 2 pi FL. F changes, then X changes. Rotor reactance at standstill, yes, in this also is going to depend. Rotor resistance is not going to depend. Okay, so option D is wrong. Okay, about the maximum torque, right? Yeah. Let's go to the next question. Let's go to the next question. Yeah. The starting torque of a three-phase induction motor varies. Starting torque is also directly proportional to, yes, starting torque is directly proportional to V square, applied voltage square, right? Next, the losses occurring in the rotor of an induction motor are less than those in the stator because of, very good question, because the losses are going to depend on the frequency, especially iron losses, eddy current losses, and hysteresis losses are going to depend upon frequency. The rotor frequency is slip times of stator frequency. See, rotor frequency Fr is equal to slip times of synchronous speed frequency. Therefore, this is a slip is very low. Therefore, this is also very low. Therefore, losses in the rotor, iron losses, especially in the rotor, are very less when compared to stator losses. So, point here is smaller diameter of the rotor, less rotor frequency. This is not correct. Less rotor frequency, less rotor frequency. Option B and C both are correct one, because same options got repeated. Less rotor frequency, both are correct. Both are same options only. Okay. The relationship between rotor frequency F2 and slip S is equal. See, just now I told you that rotor frequency Ft is equal to S times of F153 is option B. The rotor copper losses of an induction motor are directly proportional to slip. Na? Yes, rotor copper losses are directly proportional to slip. Just now I told you that the rotor copper losses. See, because I told about iron losses, about copper loss also. You know, rotor EMF is E2 is actually rotor EMF is S times of E2 dash is S times of E2. E2 is the standstill EMF. E2 is the EMF induced in the rotor when it is standstill. But when it is rotating, the difference of rotation is going to create slip. That the induced EMF in the rotor is directly proportional to slip. Then correct, if I want to take I2 means I have to take E2 dash by X2 if I neglect the resistance. Therefore, that is directly proportional to current slip. That is going to be another slip. Right? Next, question number 55. Question number 55, what is saying? An SCR is considered to be semi-controlled device because, yes, it is semi-controlled because you can turn on that one with help of gate, but you cannot turn off. Okay? Yes, it can be turned on, but not off with the gate. Option is C. Option is C. Next question. A resistance connected across the gate and the cathode of an SCR is to reduce the increase the, not to reduce the dV by dt rating. Means whenever there's a huge change in voltage, sudden change of voltage, thyristor may damage or SCR may damage, to protect it from that kind of sudden change of voltage as well, because switching actions will change the voltage suddenly. Switching actions will change the voltage suddenly. So dV by dt for my SCR to withstand the change of that voltage with respect to time, huge changes to withstand, we are going to connect one resistance. The option is D. Next, track is equal to, right? Two SCRs connected in anti-parallel. We all know that. Track is equal to SCRs connected in anti-parallel, right? Next, IGBT possesses low input impedance. No, high input impedance. Yes. See, the requirement, one of the most important requirement of IGBT is to have a high input impedance, right? Next question, please. Yeah. What is the question number? The GTO is talking about what? GTO, gate term of GTO. In a GTO, the N layer forms cathode. Yes, N layer forms cathode, right? In a GTO, the layer N forms cathode. The crest factor, it is nothing but RMS value, peak value. See, please, all of you go through those crest factor, peak factor, okay, form factor, or I can say there are some more formulas in power electronics, okay, about these factors. Please go through those formulas, okay. Yeah. Crest factor is defined as RMS value by peak value. Next up, a single phase midpoint full wave. Yeah, it is full wave SCR converter with maximum midpoint voltage of Vmax. Develops an average output voltage across a resistive load at a firing angle delay of 0 and pi by 2 ratings respectively, as he is asking full wave rectifier output for a resistive load at an angles of 0 and pi by 2. What is V naught? V naught is equal to V max in by pi into 1 plus cos alpha. V max by pi into 1 plus cos alpha. So he said that alpha is equal to 0 degrees for the first time. If it is 0, cos 0 is 1, 1 plus 1 is 2. So it is 2 Vm by pi. Right? The next is alpha is equal to pi by 2. Then V naught is equal to pi by 2 means 0. It is Vm by pi. It is what? Vm by pi. 2 Vm by pi comma Vm by pi. 2 Vm by pi comma Vm by pi. 61. Right? Yes. The next question. Read the next question. Yeah. This question, there is one inductor and one capacitor connected both in series. You know, the voltage across capacitor, there is a derivation for that. Okay, that is Vs into 1 minus cos omega t. 1 minus cos omega t. Right? And he's asking at steady state. See, this will be steady state at a pi. This circuit is going to be steady state at pi. When omega t is equal to pi, what you're going to get Vc of pi is equal to Vs into 2 times of Vs it is 2 into how much is Vs equal to 20, therefore how much it is 40 volts very simply. The answer is 40 volts. Right? Next question. In DC choppers, if P1 is the on period and F is the chopping frequency, then output voltage in terms of input voltage Vs is given by. So tell me V naught is equal to Vs into T on by T. Duty cycle, right? See for how much time it is on to the total time, right? Now simply I can write it as Vs into 1 by T is frequency into Tr. So Vs into F into Tr. Vs into F into Tr. The option is B. Option is 3. Let's read the next question. A step-up chopper has an output voltage of 5, means V not equal to 5. He's saying that V not equal to 5. And the average output, no, input voltage is 5. Sorry, I wrote wrong. Input voltage is 5. Input voltage is of 5. Output voltage is 20. Yeah, it is a step-up chopper. Na? It is stepping the voltage from 5 to 20. Then the duty cycle is, what is the formula? V naught is equal to Vi by 1 minus alpha. Input voltage by 1 minus alpha. How much is the input voltage? 5 by 1 minus alpha. I want to find. How much is V naught? 20. So 5 by 20. 5 by 20 is equal to 1 minus alpha. It is 1 by 4 is equal to 1 minus alpha. That implies alpha is equal to 1 minus 1 by 4. How much it is? 3 by 4. Option is 3 by 4. A is wrong, B is wrong. Let's go to C and D options which are on this page. So option is C, right? Option is C. Read question number 65 carefully. Read question number 65 carefully. What is saying question number 65? Yes. Hello. Yeah. In question number 65 is saying that a chopper is there. Yes, a chopper is there. Yeah, he's saying that a chopper is used to control the illumination of a lamp having 20 ohm resistance. Fine. So load resistance is 20. The DC supply voltage is 120. That is also fine. 120. If the power dissipated in the lamp, it is not lamp. In the lamp is 180. Means the power P is equal to V into I naught. V into I naught. Okay. Okay, is 180. What is the value of the duty cycle? What is the value of duty cycle is asking. So we know that V naught is equal to root D into Vs, where D is the duty cycle. And we know that power P is equal to V naught into I naught, right? Sorry. Yes, P into P is equal to V into I naught. It is 180, man. It is 180. So how much is the voltage? 120. From this, you are going to get I naught. How much is I naught? It is 18 by 12. Yes, 18 by 12. Right? So it also can be written as V naught square by R. Na? Yes, it also can be written as V naught square by R. Yes, check it, calculate it. How much you are going to get? 18 by 12. 18 by 12, how much you are getting? Yes. 18 by 12. See, you can get current na, this way. You can get current. Yes. So V naught is equal to, come to this formula. V naught is equal to, I can write it as I naught into R, because given R is equal to root 2D into Vs. Root 2D into Vs. Right? How much is I naught? 18 by 12 into how much is R? 20 into root 2D into Vs. How much is the supply voltage? How much is given? 120. From this one, you are going to get the value of D. You are going to get the value of D. Please calculate it and let me know. Okay. Please do the calculation. Now, next one is question number 66. Question number 66. Read it. He's asking about. Yes. For a DC-DC boost converter circuit, the order of connection of components LCD MOSFET switch between the supply and load from the left to right is okay. See, I'll draw this diagram. Just you only tell me the possible option. That is, yeah, voltage source, inductor, switch. Yes. Now tell me which one is the possible option. So, as options are not visible to you, observe L series, switch series. Yeah, this is switch. Switch is not in series. This is L. This is D. Yes. Option A is wrong. Switch series. Option B is also wrong. L series. Okay, satisfied. Switch parallel. Okay, satisfied. Diode series. Okay, satisfied. Capacitor parallel. Yes. Okay, satisfied. Here is the load we are going to keep. This is the load. Option is C. Directly. Right? Yeah. Sorry for the interruption. Yeah. Here the next question. Large size steel plants and nuclear plants are suitable. Any large size plant is suitable for base load plant. We are using any large size plant as base load plant. Okay. It is used as a base load plant. Next, a power plant which is most efficient but has high initial cost is hydel. And because no fuel cost. If it is thermal, nuclear, whatever it is, I can say like there is some maintenance cost is there, fuel cost is there, but in hydel nothing, water is for free. But only cost of that highest cost is initial cost because we have to construct big dams. Okay, this is a hydraulic power plant. In hydropower station, such tank is provided. Is provided to control the pressure. Okay, control the pressure variations in pipes and the sudden load variations. 69 is A. The concept of an electrically short, medium, and long line is primarily based on wavelength. See, physically short is different, electrically short is different. Electrical short, medium, long. There is no medium in electrical. In electrically, either there is short or long, but not medium. Electrical length means wavelength. See, whenever you see the word electrical, you have to see the wavelength, but not physical length. Next step. A transmission line is reciprocal. The condition for reciprocity from network analysis is AD minus BC is equal to 1. The condition for symmetry is A equal to D. All practical transmission lines are symmetrical as well as reciprocal. Otherwise, there is not a practical transmission line. Okay, all water from the transmission line you feel it as practical. It must be symmetrical as well as reciprocal, right? Yeah. Let's come to the next question. Yeah. A short transmission line voltage regulation is 0 when the power factor angle of the load at the receiving end side is. What is the condition for zero voltage regulation? Phi r plus theta is equal to pi by 2. Where phi r is load angle. So phi r is equal to pi by 2 minus theta. Where theta is equal to, it is a transmission line impedance angle that is equal to tan inverse of x by r. Now if you put that phi r, it is not phi 2. So phi r is equal to pi by 2 minus tan inverse of x by r. Now if you apply tan on both sides, tan phi r is equal to, we are going to get cot theta. Cot theta is the reciprocal of tan theta. Yes, it is 1 by tan theta. So tan phi r is equal to, or not, see, this way it is not correct. Yes, just let me, that is. Yeah. So from this one you do, from this one, this relationship you do, apply tan both sides, you are going to get a tan inverse of r by x you get. Yeah, tan inverse of r by x you are going to get. See, tan theta if you want, you are going, if you take right angle triangle, if this is theta, this is r, this is x, what is tan theta? Tan theta is opposite side by outside side. What is cot theta? Exactly, it's a reciprocal, right? Apply tan on both sides, you're going to get tan inverse of r by x, right? Next up, the receiving end voltage of a long line under no load condition is, the receiving end voltage is going to be more than sending end voltage due to Faraday effect. So it is going to be more than sending end voltage due to what effect? Faraday effect. Faraday effect. Next step. A DC three-wire distributor system requires how much copper as compared to DC two-wire distribution system? Only 5/6 of copper. See, there is a big derivation from that. You just please remember this formula. Just please remember that formula. Only 5/16 of copper. See, three-wire requires when compared to two-wire, right? 73A. No, no, no. Why 73A, Mr. Nikhil? 73 is not A. 72 is B. Yes, 73 is not A. The receiving end voltage is going to be more than sending end voltage because of Faraday effect. There is an effect called Faraday effect which we already studied because of the transmission line under no load it is. Yes, under no load. It clearly mentioned under no load. If it is a loaded condition, it is maybe that depends on the load. Suppose load is less than surge impedance loading, more than surge impedance loading, equal to surge impedance loading. A lot of stories there. Okay, next one. Which of the following distribution system is more reliable? Ringmain. Ringmain is more reliable. Why? Because even one part is disconnected, another part will get the continuity of power supply in Ringmain. Right? That is the advantage of Ringmain power system, Ringmain distribution system. Next, question number 76. Distributors are designed from the point of view. In distribution, the main consideration is voltage drop. We have to design distributor in such a way that low voltage drop is there. We have to design transmission line in such a way that low power loss is there. Because in transmission, voltage drop is also there. We don't bother. But power loss is important for us, right? Because we are not connecting any direct consumer to the transmission line, but we are connecting direct consumer to the distribution line. If the voltage drop is high, and the receiving end voltage to the consumer is less, then consumer is going to feel unhappy and is going to complain. See, it is not giving quality of supply, right? You are giving at low voltage, which is not useful for him, and his equipment also may damage, right? Next, this question 77. So the here option is voltage drop. In point of view of voltage drop in it. For a given base voltage and base voltages, the per unit impedance value is X. For the double base values, if both voltage and volt amperes, the per unit impedance will be this direct formula. Direct formula, nothing to do here. So Z per unit nu is equal to Z per unit old into V base old by V base new whole square into S base new by S base old. Now, if this is the case, X per unit new is equal to X, Z per unit old is X into, he's saying that everything is doubled. This is doubled. This is doubled. Doubles, see, this is 1 by 2. 1 by 2 whole square is 1 by 4 into, this is doubled. This is 2 by 1. This is 2 times. Simply it is going to be 0.5 times of X. It is 0.5X. Option is C. Next question. It's also the same formula. A transmission line has a per unit impedance of 0.5 and at 500 MVA and 130 kbase. The per unit impedance on the base of 200 MVA will be only change in MVA. Voltage is same. So Z per unit new is equal to V base is same. So Z per unit old, how much it is? 0.5 into S base new 200 by S base old 500. So 2.5 it is 0.5 by 2.5 is the answer. Like if you solve, you'll get. That's all. Those are not big questions. Okay, general questions. Those are and simple questions. Next, what is the preferred CB in extra high voltage system SF6? Yes, in HV we are going to prefer some SF6. Okay, SF6 we are going to prefer. The use of high speed circuit breaker to improve stability. Yeah, instantly I discussed that. Yes, I said that. See, use of high speed circuit breakers will improve the stability because as and when the fault occurs, it has to be cleared by the circuit breaker. Okay, or the faulty section must be disconnected from the healthy section. Otherwise, after some time, what is the time? Critical clearing time. Even at the critical clearing time, also the fault is not clear. The system will become unstable. This one I will explain in class. Right. Next, here question number 81. The rate of rise of restricting voltage depends on type of circuit breaker. Nothing to do with the type of circuit breaker. Inductance of the system, yes. Capacitance of the system, yes. Therefore, the option is both B and C. Both B and C. 82. Question number 82. Yes. For protection of distribution line, the following circuit breakers may be considered. Distribution means low voltage. See, bulk coil circuit breaker, air blast, air circuit breaker, vacuum circuit breaker. 1 and 4. These are the mostly used. These are the mostly used circuit breakers for, I can say, protection of distribution lines. Next, the breakdown strength of SF6 at SF6 gas at NTP is, yeah, it is a 3 times that of air at NTP. Yes, yes, it is 3 times. Okay, 83. Let's go to the next question. Next question. Yes. Circuit breaker is used for which of the following? What is the purpose of circuit breaker? Voltage control. See, this is one of the simplest question I have taken. Not for voltage control, power control, no. Frequency control, no. Overcurrent protection. Yes, I want to protect my system from overcurrent. So then I am going to install the circuit breaker. Right. Next time. SF6 gas has excellent heat transfer properties because of its high molecular weight. Yes, its molecular weight is high, and a low gaseous viscosity. Yes, high dielectric strength. No, A and B are correct. A and B are correct. See, we taken this paper, mock paper, by just referring to the previous papers of HPCL. See, if you go through the previous papers of HPCL, the question paper level is of this kind only. Maybe this year, as they introduce negative marking, the level of the question may be little, I can say, tougher than the previous papers. Little, I can say, tougher. See, the more tough it is, the more advantage for you. Why? Because if it is easy, everyone will answer. If it is tough, then only the person who really prepared can answer the question. Right? Yeah. Thank you. Contact YourPedia team if you want this question paper and solutions. Yeah. Contact this number if you want this question paper, complete question paper along with solution PDF. I'll be sending you if you message me in the WhatsApp. Thank you. All the best.